Today we are going to look at the sine rule and to find out when is it applicable for us to solve triangles which are not right angle triangles. Remember, formerly we had looked at solving right angle triangles using either a combination of the Pythagoras theorem and the trig ratios. Now we are looking at triangles which are not right angle triangle, and we are going to look at this time at the sine rule. There is one more called this cosine rule, which we'll look at in another video. Now, in the first instance, if you are given two sides and an angle which is opposite one of the given sides. So in this case, we have side mark B here, which is given, and side mark A, and the angle A is opposite the given side here. So we have the conditions for us to use the sine rule. In the next case, you have to have two angles and a side opposite one of any of the angle. In this case here, we have the angle at Q and the angle at R given, and we are given the side Q, which is opposite the angle Q. So we can find side R or P using the sine rule, which we are going to take a look at an example of how we do that. Before we do that, we are going to look at what exactly the sine rule is. If you notice in the diagram here, we have the angle A, which is opposite the side A, and likewise B, angle B, and side B, and angle C and side C. So the sine rule deals with the pairs of the angle and the side opposite the given angle. So the rule states when we want to find sides, we use this format, the first format. A over sine A is equal to B over sine B is equal to C over sine C. If we are going to use it to solve for angles, we use the inverse of that the rule, which is the sine of A over A, or the sine of B over B, and the sine of C over C. And remember, we use this rule when given one of the two conditions which we discussed earlier. Now we are going to look at its application. We are asked to work out the length of x in the diagram below. Let us see if we have the condition. We have two angles, angle at 60 and angle at 80, and we have a side which is opposite one of the angle, which is 7. So we have the conditions. So what you would write is, you write the unknown x over the sine of 80 is equal to 7 over the sine of 60. Then we're going to proceed to solve that equation. We're going to isolate x. So we're going to multiply both sides by sine of 80, and we get 7 times sine 80 over the sine of 60. Now we're going to use our calculator to evaluate what sine 60 is and sine 80. So we get 7 times 0.98, 0.9848 over 0.8660. This gives us 6.8936 divided by 0.8660. 0.966. When we calculate that, we get the length of the side x to be 7.96 units, and this is to 2 decimal places. Okay, we are now going to look at the solution of an angle. Now we are given two sides and we are given an angle, two sides 8 units and 10 units, and an angle opposite one of the given side, which is 75. So we want to find angle M. So we use the inverse of the set up the one to find the angles. Sine of M over 8 is equal to the sine of 75 over 10. Now that gives us, we're going to have sine of M, angle M is equal to 8 sine 75 degrees over 10. We evaluate what sine 75 is, and that gives us 8 times 0.9659 divided by 10, and simplifying we will get 0.7727. Now we have not found the angle M as yet. This is the sine of M. So in order to get the angle M, we use the inverse sine of the number to find out what the value of the angle will be. And we look up in our calculator, and that gives us approximately 50.62 degrees to 2 decimal places. So these are the instances in which we use the sine rule. Thanks for watching.